Okay, so this is going to be the second video in solving log and exponential equations. It's going to be a lot like yesterday's, except that today you're going to be using a calculator. All right, so it's going to be about using the log button on your calculator and also being able to leave stuff in calculator ready form, which you saw yesterday. Okay, so here we go. Here are some tips, and you've seen some of these before. Okay, so I can't change 3,000 to be in base 6, all right? It's impossible. So I am going to write this in the other form by doing, this is the base, and this is the exponent, and this is the answer. So it's going to be log base answer equals, sorry, that's 3,000, equals exponent. All right, and then, again, if I'm solving for x, I can just divide both sides by 5. All right, so this is the part where I really need this to make sense. So let me make sure I have this written up here correctly. So I now know that x is equal to log base 6 of 3,000 over 5. That answer right there is calculator ready, okay? It's completely accurate, it's perfect. I will accept it if you don't have a calculator. Now, if you do have a calculator, you're gonna have to learn how to type in log base 6 of 3,000 in your particular calculator, and every calculator is slightly different. So if you need help, if you can't get the decimal answer that I'm about to put on here, come and see me and I will help you with your calculator. If you don't have a scientific calculator, I can show you how to do this in Desmos. Okay, but the answer that you should be getting is 0.8937. All right, and that's a rounded number, but that's to 4 decimal places. All right, let's keep going. Okay, so for this equation, the stuff that's here in the parentheses is the stuff that has the x on it. So I need to isolate that as much as I can. So first thing, I'm going to subtract 15 from both sides. All right, and then I'm going to divide both sides by 6 and get 8 to the negative 2 minus x equals 381. All right, and then I just know that I cannot get this to be written in base 8. So the only thing I can do is to write this in log form. So it's log base answer exponent. And again, I'm trying to get this x by itself, so I'm going to add 2 to both sides. And then if I multiply the whole thing by a negative, I should get what x is. So I'll have negative log base 8, 381 minus 2, because you have to distribute. All right, this is considered to be calculator ready form. You're going to put that in your calculator and come up with a decimal. If you cannot get this decimal, again, come and see me and I will help you with your calculator. But the answer should be negative 4.858. And again, this is a rounded digit, but hopefully you're getting this in your calculator. Again, come and see me if you need help. Okay, let's keep going. Okay, now this is in base E, which means when I change it in a little bit into log form, it's going to be natural log form, but that's okay. So I'm going to divide both sides by 4 because I'm trying to get the E by itself. So I have e to the 2x equals 10. I'm next going to write this in natural log form because my base is e. So the natural log, the base is e, you don't have to write that. Answer equals exponent. Again, we are trying to solve for x, so we divide both sides by 2. So now I have this. I have the natural log of 10 over 2, which is calculator ready form. This is ready to go. That does not equal the natural log of 5. All right? This entire log is being divided. Okay? Again, be very, very careful. Put it into your calculator, and you should get 1.153. 1.153. Again, that is a rounded answer. Okay, very similar problem here. I'm going to add 14 to both sides to try to isolate this base. So 3 times e raised to the x equals, what, 25? Next, I'm going to divide both sides by 3. All right, and then last, I'm going to write this in log form because I'm trying to solve for x, and I can't solve for x when it's an exponent. But if you write it in log form, in this case natural log form, that exponent is no longer going to be an exponent. It's going to be on the far right hand side. Base answer equals exponent. Okay, so this is calculator ready form. But again, you're going to put this in your calculator and get this decimal answer. 2.120. Okay, and the natural log button is usually very, very close to, either like right next to or above or below the other log button. Oh, and I obviously misnumbered this. This was number 4. This is now number 5. Okay, so let's see. This is in natural log form, but I can't solve for x because it's sort of trapped right under the log. But I can rewrite this in the other form. So this would be base of e raised to the negative 2 equals x. Again, calculator ready form. But then when I actually put it in the calculator, you'll find out that x equals 0.1353. 0.1353. The E button is going to be found when you hit second natural log. Okay, they're connected. They're right next to each other. All right, let's try example 5. Again, this is almost the exact same as the last one. The base is E. The exponent is 1.5, and that's going to equal 2x. The only added part here is dividing both sides by 2. Okay, so x is equal to e to the 1.5 divided by 2. This is calculator ready form. But when you actually put it in your calculator, you should get 2.2408. 2.2408. All right, so for this one, I'm going to, this is actually kind of cool. I like this example because we haven't really talked about common logs, but I'll get to that in a minute. All right, so for this one, I'm going to divide both sides of this equation by 4. So I have log base 10 of x minus 6 equals 11/4. And then I'm going to take this out of log form and put it into exponential form. Okay, so it's going to be 10 to the 11/4 equals x minus 6. All right, and now that I have this x no longer trapped under the log, I can add 6 to both sides. So I have 10 to the 11/4 plus 6. That's what x equals. That's calculator ready form. And when you put this into your calculator, you should get 568.3413. Oh, and that's the last example. All right, thanks for your attention.